Hi, Gerard. It's me again. I finally figured out exact positioning of the slasher controller, which I figured out in relation to the rotor of those washing machine motors. Uh, I draw it like this, as follows. This paint program helped me out to represent the sequencing and find all my errors I had before I got the proper sequences. You can see here I am showing you all the drawings I did, messing me up with to find the proper sequence, but finally I found out how to represent it. It uh, to explain the picture, I'll say here we got a drum motor. Okay, as you can see, these three lines: yellow one, the purple one, the middle one, and the black one, the third one, are the faces, right? Each one of them is connected by a brush to the open. It's the slasher, but it's not sequenced. Okay, it's always connected. As you can see, that black dot there, the purple one and the yellow one, I try to express there always connection. There's always connection there. Okay, so then we have the positive of the DC current applied to feed the motor. Okay, it's supposed to be those 310 volts minimum, as it's required for the motor. And they are it's distributed by three brushes along the same line. Here we got the minus, right? It's the same way, but it has two connections instead one. It's it's double the surface of the connections there, because if there was only one connection, we got only the positive to the negative, but there wasn't any coincidence in the other two for the minus connection, so I had to add another negative connection. As you can see, there are two dots, all the others are is one dot. And here we had the set. That set is the is supposed to represent the moment the Anaheim controller says there is all the transistors off, right? They're all closed, but I figured out it could be another connection in this controller, right? I show you the timetable of the Anheims. That set is, it says below that it's when all the connectors are off. So what I figured out is, as you can see, if we take this one is representing three of those squares, represents one pole of the four pole stack of magnets. You see, this light green is the stack of magnets, the dark green is just one pole, right? And as you see, it it is represented by three lines of squares. So each pole is three squares, three three steps, right? So each step, let's say, is a straight line here of squares. So you can see the blue positive connection is all along a straight line, right? And the slashing connections are are distributed one one upside up and one step further one from the other. So there is the sequencing represented as like that. And as you can see in this instant of the connection, because this all this orange is representing sorry, the copper, right, or the conductive material of the cylinder of slashing, which is our connection, right? So for this instant there is here the positive into this. Those are separate one from the other, right? As you can see, here is only the black phase connected. To this one is the purple phase connection, and this one is the yellow one, and they are not connected uh, between them in this part of the circuit, right? They are connected in the drum motor only, but here they are independent. So as you can see in this instant, we got positive here in the black one, and it will transfer the current right through the copper. Here will pass the connection of the phase, right? Another brush, and then it will have the minus here. So I figure out from positive to negative here, it will feed up the motor also, right? The current will flow from here to the motor, um, besides it's flowing from positive to negative. Okay, if it's not like that, I'll thank you guys. Say what you think you have to say. Then you can see from this instant, here is no positive connection in this other phase, in this purple phase, and here also it's not connection in the yellow one also. So you can see for this instant of the sequence, I represented it by those symbols here, symbols. Those are the first one is the instant which I got. This was directly represented, right? You can see the black one is positive, so it's the positive time. I was trying to represent exactly how this Anaheim controller, um, how timetable was showing. I saw there was positive Z minus, right? Let's stay with that. That's what I wanted to do. I got more things to say about this, sorry. I will say after. As you can see, here it corresponds that the set should be the yellow one, right? So that's the other step of the timetable, and the purple one will be the connection of the minus here. So everything is working properly, right? As you can see. Then one step further, I imagine all those orange parts moves uh, one square down. So what happened? You can see the orange connection will be on that blue brush spot. That those are representing the brushes. Sorry, somebody is missing here. Uh, so the next step, this brush will be a connection, and this red spot below for the minus, it will be connected. So current flow here, and the purple phase is receiving voltage. So it's positive. The set connection won't be anymore in this yellow line. It will be on the here on the black one, right? Because we are taking account that the slasher is spinning down, so all the connections moves one square down, and the set part, it will be the black one. the black phase, right? You see this phase, and then as you can tell, the yellow one will be connected to the minus only, right? Not positive, but to the negative only. So the current is supposed to flow in this step, right? The second step, from here to here. And so the current will come here to the motor by the purple phase, will spread around the motor, and it will get out by the yellow phase because it's the minus one, and it will go back to the brush and then back to the minus again. And the Z1, which is the black one, will be on contraction, right? It will be pulled, it will be sucked in like a vacuum, as I told the video before. But that we Z connection I represented because I think we can get voltage out from that instant, right? Instead counting it like it's everything closed, right? By simply not connecting this, right? By simply leaving this with nothing, right? I counted that we can make another connection here to check what is coming out when the anhydride stays all closed. So that will help to make a little more tests to this. And I figured out that this way was the proper way, right? Then I thought, okay, I got it. So let's see the Anaheim timetable, right? And I thought that because each step was always plus Z minus, right? What was repeating, I had done it properly, right? Because that was the sequence. Plus, one was the Z closed, and then the minus one, which everything went through it. So, but I thought when I saw this again, I got pissed off again. So funny because I said, okay, what? It's not right because you say step 1, 2, 3. There is one step that there are two minus sequenced one after the other. So I thought, okay, I'm wrong again. This sequencing is not okay, right? Maybe I have to do another sequence. And I went down and I tried more sequencing shit, and after a lot I said, okay, no way, I couldn't find it, and I said, okay, but what's wrong? And I was watching this table again, and I realized what I was talking about the last video again. This second step is when the sensor B, right? Let's say we start with the first, let's call it first sensor on, right? And the others are closed, right? So the only entry we have is the next sensor, right? The second sensor. When it gets on with this one here represented, it's here represented that the positive which was before gets closed, right? And there is open the next phase, right? The phase which was open before gets closed, and we open the next phase, right? And the minus doesn't change, right? So this step, I think it could be omitted completely, right? Because it doesn't fucking say anything but making confusion here. I don't know. making misunderstanding to me because this just says, okay, the phase before gets closed, so it gets high impedance, as it says, which I don't know what it means, but it's the only thing what this step is telling, right? It's telling when we close this phase A, it gets high impedance, because what is the next step, the number 3, is exactly the same, right? But the positive doesn't change, and the Z is where it's supposed to be, and the -2. So if we omit this step, which says nothing too, because it's, as you can see, physically in the drum motor. I'm gonna show you another. Here I represented. Here is the for you guys to see it better. Here is where I represented. Here the arrow is pointing to the middle between two legs, right, of the motor, which is this orange line, the legs, and here is pointing between of them, and those are the poles only, right? Each gray segment is one pole. So as you can see, when there is the middle of the pole between two legs, it's the time where the sensor gets activated, right? That's the time where the timetable should put the 1, right? From where there was a 0, then there is a 1. That is this instant, right? So as you can see, when we move 1/3 of the pole, right? Let's turn the other way, sorry. I move 1/3 of the pole, and this time here is this pole at the middle of the next hole, space between legs. So this time the next sensor will be activated, and so on. 1, 3. Sorry, let me do it again. 1, 2, 3, 4. There is the next one, and then 1, 2, 3, 4. Here will be the next one, and as you can see, that is 1/3 of each pole. When the poles moves 1/3 of each of its length, right? There is another input, a new entry of the sensors, right? So what this timetable is telling is that when is the activation of the next sensor, which will be 1/3 of the pole, right? I moved the middle, which was here, the red, 1/3 of the length, and there is the new turning on of the other sensor. So that's this point, the second step. We have the new entry, and here jumps immediately to the third step, because automatically when the second sensor turns on, the first one turns off, and that is the representation of the third step, right? So this second step is not what we have to represent exactly in the sequencing, because it's not what we had to represent in the sequence, as it says here, positive Z, double, negative negative, Z, positive positive, right? That's not what we are looking for. We are looking for positive, then Z, then negative, then positive again. So let me show you. I'm telling this just is gotta be omitted. I think I explained myself properly, but if something missing there, I will try to do it better. But this step is only telling that instant when both, as I said, this connection keeps open by the board, but in the instant the next sensor gets activated, the first one turns off, and that's not another step of the slasher which we will have to take in account, right? Because what we have to take in account is the third step only, from the first one to the third one to the representation, right? This step is just infinitesimal when there's a new entry or a new turning on of the next sensor, right? Sorry, I'm shaking my hand, so the camera is shaking too. Sorry. If we omit this sensor, we don't take into account this second step, and we jump to the third step, is the representation we have in that sequencing picture I show you. The positive passes to negative, then here again this gets to be omitted. So we've passed from the first one to the third one and to the fifth one, right? The second one and the fourth one omitted. And what do we got? We got, as you can tell, phase A turns positive. In the next one, the phase B turns positive, and the third one and the fifth one turns the other phase positive, and the same thing for the other situations, right? So it's correct, I think, right? If something missing, please make me know. I have more things to say, I think. As you can tell, this is the sequencing again. I wrote this because I said no coincidence with the timetable, right? But I realized that the timetable wasn't representing exactly what it had to be manifested by the sequencing. There is that step omitted. I said will be here also, but it's nothing but taking into account that when one phase passes from being opened, so positive, to the next step, it gets closed and it receives high impedance, or it's high impedance. That was pissing me off of that timetable from the Einhein's, but this will work exactly as the Einheim does, as you can see. The other thing is, okay, I said this is the proper sequencing, right? And then instead separating, as you can see, this stairs, moving one from the other one step down, so making it like a ladder. I represented them all straight, as you can see, all straight, and sorry, and here what is separate is the brushes, right? So for the piece of the slasher to be all straight, and then the brushes is which are separate in degrees from that cylinder from one to the other to make the sequencing. Or you can go the other way, right? If it's more difficult to align the brushes in different altitudes, right, in different degrees, which is as I think maybe it's better to separate one step from the other, the the machining of the hole for the slasher copper plate, right? So the brushes will be all connected straight line, as you can see here. And that's other thing. I was taking account how to put the brushes, and I figured out this way. It's sorry, it's just a piece of plastic, I will say, and I thought about, you see that this shape, right, which will the brush will be located here, and then here's the spring of the brush or whatever, and then here we have another piece of plastic with a screw which can push another piece of plastic to tense the spring of the brush against the slasher, which will be there. So somehow to some way to dispose the brushes, and then it will look something like this, as you can see. I represented to the length of the connection lines of the slashing. This is, as you can see, that the same is, it will be 5 millimeters. I got here the calculations. It depends of the diameter of the cylinder of the slasher, right? It's if it's 300 millimeters, sorry, if we have 300 millimeters, this length here of the connection is 2.1 millimeters. If we have a 200 millimeters diameter slasher, it is 4.3 millimeters. If it is 300 millimeters diameter, this length will be 6.5 millimeters. As you can tell, this picture, each square are 5 millimeters, so it's very accurate to those 6, which will have a 300 in diameter, which is exactly like this rotor has. So this is very accurate to the real length. It will have, let me dispose it properly. So it will be like a cylinder here. Oh fuck, I'm not holding it properly. Like that, you see? Those are 5 millimeters each, so for a 300 diameter, which is exactly this out diameter, it will look like this, and it will be a little thicker. A piece of plastic here with those 3 lines of connection of the sequencing, and other thing, I think that's all. It's everything explained. Yes, wanted to say each one of those 3 squares is representing what is related in relation to the washing machine motor. It is one pole, right, which is 2.5 degrees of the 360 degrees of the whole motor, right? And each stack of magnets, not sorry, each pole is 7.5 degrees, right? And for each pole we need to represent 3 steps, right, as I show you before. For each time here, the motor, sorry, the here, for each time the pole moves 3 1/3 of its length, there is a new entry of sensor. So for each 1/3 of the length of the pole we need to have the 3 sequencing, right? So this is representing one pole only, the length 7.5 degrees, and each section of each one of the 3 steps is 2.5 degrees, right? So I think that was all I have to say for now. There is still to be represented how to connect, how to dispose the brushes, the carbon brushes, right? Or maybe other method for the brushes. I thought maybe metal brushes, right, instead of carbon brushes, because they will uh, they won't burn, right, and they won't make to don't have to replace them too oftenly or something, right, to make it live longer, right, or something. So they won't have to be replaced so oftenly. I don't know, so that's something still got to be done to me. So I think that's pretty much it about the entry of the positive. uh, I don't know, whatever, with a regulation for the output of voltage, right, to regulate manually the input of voltage, and then it keeps it stable, right, like a turning steering wheel switch. I don't know how to call it better. Just to adjust the voltage which is entering to the slasher, and that's it. If you have something to say about it, I think I would be glad to hear it, and see you soon. Okay, sorry, wait up. Something missing here. Something I missed to say is about the positioning, right? Uh, as you can see here in this motor, it I took in reference this straight line between those holes because they were pointing to exactly the middle between two legs, right, to the positioning. So this will be the sensor positioning, and I took account in alignment to this imaginary straight line that will be the positioning of completely one positive brush to the connection of the slasher, right? As you can see here, when there is this time, right, the sensor gets activated because the middle of the pole is between the middle of two legs. Then we will have to have exactly, as it's a new entry, right, the full brush over the in the middle of the middle of the brush in the middle of the connection. So that's the positioning, exact positioning from the stator and the rotor to the slasher controller. That's the exact positioning the Anaheim is taking in account, I think. So now that's all. I think. Get you later. Hi, sorry, it's me again. As you can tell, those who know me are not pretty much concentrated. So I forgot to say other thing. It's about the ending of the connection here. As you can see, this is like straight segments of lines which comes out of a closed loop, right, from the cylinder of the slasher controller. I don't know if it will be better to make it closed here, like adding more copper, right, here, like if will be all closed, right, like this. But I'm not sure if it will be better to keep it open and just put some other strap here to hold all these teeth in place. Put a strip there to hold them, which some strap of not conductive material, so this will be always just one direction here and not spreading in two ways, right? It will come this way and this way. And also the thickness of this copper plate, I'm not sure which should it be. I think the thinner the better, right? Because if it's not, it will be too resistant there or something. I would like to hear something about it. Uh, uh, that's all for now. See you. Sorry, now I realize other thing I forgot to say is that the positive connect brushes, right, should be the face brushes, right, should be between the positive and the negative, but but I think keeping this distance as close as possible will help the circuit to work better, right? Because it won't have to travel through many to keep this path short, right, from the positive to the negative and the faces between. So it could be just all adjust in like in this space, right, instead of having it like, let's say, positive here and negative here, right? So it has to travel every time and then enter to the face, right? So better to keep it like, let's say, positive is here, here are the faces, right? Imagine this is the slasher controller. Here we have the positive, here we have the negative, and the face is just there, right? So the transmission will be in a shorter distance than if it is spreaded in different points, more distant one from the other.
Catch you later.
Hi, it's me again. I realized something after recording all the other videos. It's about the minus connection. I thought it was a mistake to only have one step connection, but so in the other videos you can see there are two connections. It's double the surface connection of the positive, but I realized it's better to keep it one the same surface area of the connection, because I realized if there was both here was connected in the other video, right? It was like this. Oops, sorry. It was like this. Connected this one also, right? Like that. And the other ones were also like double the surface, but it's not. It's better to leave a. Sorry. Oh fuck. It's better to leave it on a straight line, yes, with the same surface area of the positive, because I realized instead of passing from here to there, this point will make it suck from here and less pass through the motor itself to come out through the minus, which is in the first step of the sequence. It's the purple one. So instead having another connection on the same phase, which is receiving positive, to make it pass from here to there, and it will be half of the current only, maybe, to say something, which will come to the motor and then to the purple line and then to the minus, right? This way is better, because the positive will come to the black one, right? And through the black one it will fully go through the motor just one direction, right, as you said in other videos, and it will come out through the purple one here and then go to the negative, right? That is making uh, uh, the full current to flow through the motor, and not as I draw in the other video, to have two minus connections instead of one, right, on the same time. So that's something you said in other videos, just to go one direction, right? One direction only, not multiple directions. So that's something I realize, something to be said. Something I was mistaken. Okay, thank you. See you next time.